Hi, I'm Sam Roberts from Roberts Geospatial Engineering. Today I'm going to continue on my series of videos where I'm creating topographic maps at high resolution in ProRaster. Then I'm uploading those to my phone so that I can use them in Handy GPS, which is the GPS application that I use when I'm out bushwalking or mountain biking. So I'm going to be using ProRaster Scientific today. On screen is the ProRaster webpage at robertsgeospatial.com.au. You get ProRaster in either ProRaster Essential, Premium or Scientific from the Microsoft Store. So my topographic maps primarily consist of very high resolution terrain data, and that terrain data comes from LiDAR. So in this video, we're going to do this from scratch, although we're going to skip the processing and just show you how to go from LiDAR to virtual grid to actual grid and then to our topographic maps. So we're going to be working in the Warrumbungles, which is a national park in New South Wales in Australia. So I've downloaded, what do we got here? 347 LAS files, which was a survey of the Warrumbungles National Park. And now, in order to turn these into data that I can use in ProRaster, I'm going to import those LAS files into an MRP file. So I go to point processing and I go import LiDAR and select the import LiDAR option. Here's my import dialog. Now these are all LAS files. I'm going to go and select all of the LAS files in that directory. So there's the directory, hit OK. And you can see that it's brought all of those in and you've got a list of all the LAS files here. I then have to specify my output file name, so I can choose some file name. I should create I should set the name of this MRP, just one of the useful properties that you'll find in the MRP file. I almost always will produce a small text file which contains information about where this data set came from, how I downloaded it, what the usage restrictions are, what the attribution requirements are. And that'll just be a little text file. And then you can put this in as your XML metadata. Just browse to that text file, select it. That will get stored in the MRP file, and you'll be able to see it whenever you open that MRP file in ProRaster. Now, the coordinate system has been set. So we've got map grid of Australia. It's picked that up from the LAS files, so I haven't had to do anything with that. I can specify my vertical units, which are going to be in meters, and then I have to set the cell size. So this is one of the most important steps. And it's also a little bit counterintuitive. Why do I have to create a cell size for a point cloud data set? Points are not stored in cells. Well, the answer is the MRP file is really an MRR file. It's actually a raster that has been reused for storing points. And there are some really great advantages for ProRaster doing it that way, because I can bring in an MRP file that has, trillions of points, and all the memory management is just occurs automatically through the raster system. So there's no additional coding required or anything, any kind of caching system required for loading up these huge point cloud systems. So that's why it's in this format. But you need to set a cell size. And what you should aim to do is you should get a certain point density. So when we're talking about LiDAR, we're talking about pulse and return. So for each pulse, you might get 1 or 2 or even 3 or 4 returns. You're looking to try and get a pulse per cell. That's the density you're looking at. So 1 pulse per cell, maybe 2 returns per cell, 1 to 2 returns per cell. It's hard to judge what that might be. So what I normally do is I import one file, and then I go and look at the statistics, look at the point densities, figure out whether that's appropriate, and then go and do the whole lot. We're going to need a cell size of about half a meter, and I'll put it in as a fraction because ProRaster likes to work with fractional numbers. It makes everything more accurate. So you can see we've got a cell size in decimal of 0.5 meter. Then I'll hit OK, and it will import all that LAS data into an MRP file. I can come back to this dialog at any time. I can repeat it. It's all going to be stored. All these settings are going to be stored, and you can do this multiple times. And there's, of course, all sorts of things that you can do. You can accumulate points and everything else. But for the time being, that's all we're going to do. I'm not going to import the data now. What you'll get is an MRP file. So here's what it would have created if we'd imported that data. Let's just get this right. So here's our MRP file. If we zoom in, you can see lots of points, and as you zoom in, more and more points come in, and you can get a whole stack of points. So let's take a look at the statistics for this MRP file. You can go to Statistics Analysis, select that file, hit OK. Statistics have already been computed, so it's not actually going to do anything. So we can go to the histogram, for example, look at the classification, and then we can see the number of returns that have been classified with these different values. Go to the spreadsheet. For example, classification 2 is a ground return. So we have got 402 million ground returns. And if we go back to our summary, you can see that in total we've got 3.58 billion returns in this data set. Now, in terms of this density information, you hit that little white button there, which is the View Statistics report in your default text editor. So it comes into your text editor. And if you come down here, you get some global point density information. So this is returns. So my global return density is 1.34 per cell. My pulse density is 1.28 per cell. So that's about what we're trying to achieve. So with our points, we can go, we're looking at Z at the moment, so that's our terrain. We can look at classification, in which case you'll want to choose the LiDAR classification color table. So our brown points are ground returns, green points will be trees, and then these purple ones or pink ones will be unassigned points, something like that. You can right click and show the data values. So if we move now over a point, it'll tell you what that is. Or you can do key plus table or all data table. And then when you move over a point, it will show it in this spreadsheet. And you'll be able to see all of the bands, all of the LiDAR information. That's all the standard LAS fields for each point. Finally, you can set your point size and everything. And of course, you can select a LAS query. Let's go to a larger point size so we can see it. So now I've got a LAS query. I've selected only ground points. And so we're just seeing all the brown points. Now we want to grid the thing. Again, go to point processing, and I'm going to go virtual gridding. Select virtual grid. Bring in that MRP file. I'm just going to make this temp 01 because I don't want to overwrite the existing one. So let's not change anything for starters. We want to grid the Z channel. That's our terrain values. We want a query. We're just going to grid ground. So we're going to select ground values. Down here, I'm going to set a cell size. So I'm going to set that to 0.5 meter. And it says that my point resolution level is 0 at grid-based resolution. That's what I want. That means all the points are coming in when you're at base level resolution. I can hit OK. Now we're gridding. So we've got a virtual grid here. Let me bring this up. And so we're gridding on the fly. We're using triangulation at the present time. I can already do things like I can draw a profile over the bread knife. This is a dolerite dike feature. You can see it here poking up. We can draw a profile over that granite tor. We're not to scale. Perhaps we should go to profile settings, set it scaled, make it a bit bigger. Oh, now it's at scale, and we can see the whole thing. So you can see that this tor is actually quite vertical, a good little rock climbing spot. I can go back now into my virtual gridding and bring up the properties again, and then I can edit my properties. What I'm going to do is go to one that I was preparing before. In this case, we've got the same data set. I'm clipping by distance, so I'm just clipping out some of that crap around the outside. I'm using tensioned minimum curvature, and I've switched on automated trend reinforcement, so we're getting a really high quality grid now. Gridding Z and ground, and so now we're making the computer work a lot harder because the automated trend reinforcement is very compute intensive, and gridding with minimum curvature in real time is also more intensive. Now, what I'm interested in is a couple of things. Firstly, there's a feature over here. It's off track. Let's swap this around like so you can see it. It's off track. That's slowly coming in. Remember, we're gridding in real time. We have a, just like the bread knife, there's another little dolerite dike in here. File over it. It's a dolerite dike, I assume it must be, just like the bread knife, which is a very well-known feature, but this one's off track and probably isn't well known at all. Quite a bit smaller, but still quite significant. We're talking about, 15 meters high, so probably an interesting little spot to go and visit for rock climbing. And there's another feature further over here which I'd like to go and visit. Again, it's off track, and you're not going to find it in the normal. But there's this kind of boulder field, a whole bunch of little boulders, and when I say little, they are actually quite significant. Oops, what do I want to do? Draw a profile. 10 meters high, probably 20 meters across. So I just think this looks interesting. Could be some opportunities for bouldering in this area. That could be a lot of fun. So I want to go out and have a look at that. So let me close that down. No, before I do that, let me just say final step. Having created your virtual raster, and if you're happy with it, you then go into raster processing and go export raster. Brings up your export dialog. Select your virtual grid, and then you can hit OK and export that out to a raster in a format of your choosing. So let's build up our topographic map algorithm. So I'm going to go to OpenStreetMaps. The Warrumbungles are out here. I'm going to hillshade this using the raster, my LiDAR derived raster, 50 centimeter cell size. And by default, that's immediately going to clip the algorithm to that area. So I'm going to turn off that highlight and bring this down a bit, this shadow scale. And again, I should be working the other way, shouldn't I? So in my algorithm for the Central Coast, I added in Google Maps and the Google Imagery. In this case, I'm not going to use any imagery, and I'm going to stick with OpenStreetMaps, which tends to be better for these national parks. The imagery contains pictures of trees. So at a very small scale, it's really not useful. All you can see are leaves. So I'm not going to use that imagery, but I am going to want to add in some contours. So I add my contour layer, select that grid. So my contour levels, I'm going to use 2 meters. And every 5 contours, there'll be a major contour. So that's our so that's every 10 meters we get a slightly thicker contour. And really, that's all I'm going to do. Just come in and take a look. So here's my target in the first instance. You can see the contours pick it out nicely. I've got plenty of shadow, so I can see other features of interest, like this little wall here, for example. Coming over to the other area that I was interested in, I think that's over here. So here's our little boulder field that I want to go and visit. And as you can see, the hill shading and the contours pick out those boulders nicely. The tracks that there are reflected in the where are we? So are reflected in the OpenStreetMaps. So here's the track that we'll be following in the Grand High Tops track. So that's going to be our topographic map. So let's just label these things. So this is OSM draped. This is our LiDAR contours. And this is my algorithm. I'll give it a name. Warrumbungle Topo. And then I need to save that algorithm. Let's see, just save that. Now I can export. But firstly, I need to clip my topographic map to a polygon. So this data set is pretty large. Whoops. I'm out of control. Zoom in. This data set is pretty large. If I was to generate that as a XYZ tile data set at high resolution, it would be pretty enormous. So I really need to clip it down to the areas that I'm interested in. So what I can do is I can I'll just turn the LiDAR contours off for a second so we can see better. I'm going to compute the area. So I'll do an area polygon, which will go all the way around this area that I'm planning to walk. And then I can right click and select area again and go save. And I usually put it into here. So this is my cheese knife walk polygon. So I'll just save that. So I can turn that off. Now, just make sure my algorithm's saved. Go into export image. Choose Handy GPS offline map. I'm going to go to sorry, I need to create a folder. Always create. Cheese knife. Select it. Select that folder. I'm going to clip to a polygon, and there's the polygon that I just created. And I'll output it at about 25 centimeter resolution, which is going to give me a raster of 5,700 by 10,200 pixels. Let's just do that and see what comes out of it. Hit process. So now it's generating the XYZ tiles. So lots of little PNG files which go into a specific directory. To get them onto your phone, you then have to zip it all up into an archive and zip it all up and then copy it into your downloads folder, and then you can access it from Handy GPS. So we can test that we've got the right thing. I can go to, well, in fact, it'll be here, new algorithm for recent output rasters, the cheeseknife.xml. So here's our data set. I am going to have to zoom in to find it. I can zoom into that polygon. And so here is our XYZ data set. If we zoom right in, we have nice high resolution contours. So I'll be walking along here. Heading up here. So at this point, we'll be going off of Gold Circuit, up this mountain, up to the peak, where we'll find our target, and then probably come back down this way, back onto Gold Circuit, and then around. Past Fibar Tor, past Makator, and all the way back then onto the main drag, and then back to the car park. So that's what I'm planning to do, and hopefully there'll be a video of that one day, but I won't be able to get out there for a few weeks because it is a day's drive to get out there and a day's drive to get back, and do a couple of walks takes a couple of days. So I've got to find some time to do that. But that's our topographic map. It's going to go onto the phone, and we'll have it when we're out at the Warrumbungles. Offline out there, no phone reception. So you've got no Google Maps or anything else to rely on. We'll be using this instead. Thanks for watching.